bit of identification. So you have three choices. We'll call them, we'll say a linear sequence is a number 1, quadratic sequence is 2, and then something else is a 3. So something else. Can you identify what type of number pattern A is? You can give me an answer of 1, 2, or 3. What type of number pattern is that very first 6, 9, 14? Do you think it's a linear sequence, number 1, a quadratic, number 2, or something different? Let's see what the early votes say. So I know I need to check for these things called differences. And when I look at the differences between the terms, I see a difference of 3 here, of 5, of 7, of 9. The first difference is not constant, but the second difference is constant. And when the second difference is constant, I know it's a quadratic sequence. So I'll just say 2. All right, now let me choose a different one. What about this one over here? What about E? Is that a number 1, number 2, or number 3? Looks like a bit of a weird one, huh? So I see quite a few students are still joining us. So welcome to Amogelang and Asande, Buchle, Callan, Ganlin, Kilabohile, Mateo, Naledi, Njabulo, Ntakeni, Onalena, Pabalelo, Pila. We have Mawe, and we have Reniwe, and we have Tamia and Tantiwe. Okay. Let's have a look. The only way I'm going to know for sure is if I test these out. So I'm going to look at the differences. So what's the difference between here and here? It is 18. What's the difference between here and here? It's 30. What's the difference between here and here? 42. Okay, and what's the difference between here and here? It looks to me like it is 54. Now, the first differences are not constant, but the second differences are constant. The difference between 54 and 42 is 12. Between this and this is 12. Because the second difference is constant, we would say that this is a quadratic. Thumbs up if you understand why this must be a quadratic number pattern. Thumbs down if you don't understand. Okay, let's do another one. What about this? What type of number pattern is that one over there? So everyone gets that this is not a quadratic, it's a linear number pattern because it's going up in 4s. Loving the chat. Okay, you guys are doing well. What about something like this? What type of number pattern is this? Oh, you guys are so sneaky clever. So we're adding 3p squared every time. So if you think about it, we add 3p squared, we add 3p squared. This must be a linear number pattern or number 1. Okay. I feel like you guys have got the basics of how this works. Let me give you one more number pattern. What about a number pattern that looks like that? What type of number pattern is that? Is an arithmetic, a geometric, or arithmetic, quadratic, something different? I did, Buchle. You caught me, Buchle. It slipped out my mouth before I gave it away. Okay, so this is not a quadratic or a linear, because if you look at the differences, like that's 10 and that is 30 and that's like monstrous. What's that? Like 60 and 30, that's 90. What we notice is that the first differences are not constant and the second differences are not constant. The way that we are going from one term to the next is we're timesing by a number. And so we call this a geometric number pattern because we're multiplying by 3 or by something called the common ratio. And so that's another type of number pattern that's possible to have. Give me a thumbs up if you understand how this is different to the other ones we've spoken about so far. Yeah, fantastic. All right, well then let's get crack-a-lacking with some old exam questions. So here is an old exam question, and it says, consider the quadratic pattern, and I want you to work out for me the value of T26. Now, if you need some hints, you can put an H in the chat, but for now, I want to see if you can fly solo with solving this exam question. Today's lesson is really just going over past exam questions on this topic. That's what we are doing today. If you would like me to give a hint, put an H in the chat. Otherwise, I'm going to assume you are flying solo and you are going to tell me the answer when you get there. Who can remember the magic steps? I suppose we always look at the differences. We kind of expected that though, because it said. Should we go back and have a peek back in earlier lessons? What are the important steps? First difference, sorry, second difference 2a, first difference 3a plus b, third step a plus b plus c. See if you can use that to help you. So feels like you have to deal with those things. What does the first block need to have in it? What does the black block have to have in it? What does the blue block? What does the green block need to have in it? So the constant second difference is a 1, it goes there. This is the first difference. So be careful. Where is the first differences? Here are the first differences. What's the first difference? It's 2. So there should be a 2 in there. The first difference is the difference between 5 and 3, which is 2. What is going to be in the green block? This is the very first term, and the very first term is 3. Now, you still need a quadratic number pattern as this setup. You need to find me what A, B, and C are using. So I'll give you some time for that. Now, how are we going to take this A and find out B? We're just going to sub in a half where there's an A. And then if this is 1.5, and I bring it to the other side, B is going to be a half as well. Because 3/2 is 1.5. Bring it across, it's subtraction. Now, how do I figure out what C is? What is C going to be? So these two go together to make 1, but I bring it other side. So C is 2. And the quadratic number patterns formula is going to be that. But the question is, what is T26? So who can tell me what T26 is? Let's have a look. Sorry, this is going to be 2. So what goes in there? It must be 26. What is everyone getting on their calculators? Let's have a look here. 26 squared times a half plus a half times 26 plus 2. I get, like Ganlon or Annalena, I see Alexa agrees, 353. I like what I'm seeing in the chat. Can you guys give me a score out of 10 for how you found this question, so I know what the next question should be like? If 0 is no understanding, 5 is like okay but needs to get better, 10 is like perfect understanding. The way I think about it is the face scale. Where are you on the face scale if it's these emojis over here? Where do you find yourself? Or emoticons, maybe they're called, I don't know. Okay, thank you for your voting. It is most helpful. Remember to be honest, because I can't always see your faces, so I have to go by your numbers. Okay, let's do another exam question. So I want you guys to first of all work out what is the next term in this quadratic number pattern. So let's take a moment and then you put your answer in the chat. Okay, now I think I need to get my calculator out here to figure out what the difference is. 193 minus 244. So the first step that I'm going to do it separately so I can 193. So this was minus 51. Then I'm going to go 148 minus 193. I get minus 45. And then I get 109 minus 148, which is minus 39. So these are the first differences, and I'm going to let you use those to figure out what do I think the next number in the pattern is. So if I look at the first differences, this is definitely a much harder question, but that's fine. We wanted to get a bit more exciting now. If I was going to say how much should this be, it looks to me like the first differences are increasing by 6. Now, it sounds weird to say increasing by 6, but basically what that means is I'm going to take away 33 to get to the next one to keep the first difference pattern going. So I'm going to go 109 minus 33, and I get 76. And if I look in the chat, I see Bukle, Asanda, Sunday, Callan, Tandiwe agree with me. Anybody else want to give me a thumbs up for 76? Are we feeling good? Thank you, Pabalelo. Thank you, Annalena. So we have done 2.1. Now I want you to do 2.2. Determine a formula for the nth term of the pattern, but remember they've said it's a quadratic pattern. Can you do that for me? So just think back to the last question. And what were the 3 steps that we used? Can you remember what they were? I must be honest, I do actually memorize them. So I just go. But I'll let you figure out what you think goes in each box. I think I need to do another round of this though. So what is going on here? I think that is plus 6. And so this must be 6. Now the question is what goes in the next 2 blocks here? Now, where is the first difference? Now, the first difference is the difference between this and this, which for me looks like it's minus 51. And then a plus b plus c is the first term, which is 244. So I'm going to make that 244. I can see that a must be 3. I'll give you some time to get b and c. What do we think b has to be? Remember, you have to take that 3 and put it back in. So when that 9 comes across, what's going to happen is I get minus 60. Anybody else get minus 60? So far I've got 3, and then here I've got b is minus 60. Now what is c going to be? What is c going to be? That sounds a bit funny, doesn't it? What's c going to be? 3 minus 60 plus c is 244. So 3 minus 60 plus c is 244. What is c going to end up being? I guess it's 244 plus 60 minus 3, because I plus minus C must be 304 minus 3, so 301. So the equation of this quadratic pattern is going to be a rather large 3n squared minus 60n plus 301. So that is this one over here. I might have gone a bit quick. Give me a thumbs up if you are okay with 2.2. That was a lot harder than anything we've done before. Yeah, okay, let's go to you. You have a question.
So I don't know. I don't know what I did. The formula that I put in the chat, it gives me both the first and the second terms in this pattern, and I don't know.
Does it give you a third one?
Let me see.
Okay. Where did we go different? Where was the change of? Did we get different A's or B's or? Oh, look at the chat. Let me look at the chat. -3. Oh, that's where we're different, Bukle. You said -3, and it should be 3. That's where the difference is. Can you see that?
Yes, I see.
Perfect. Thanks for the question. All right. Now, I need a tip from everyone. The last one for this little exam question. Which term of the pattern will have a value of 508? Who can give me some guidance as to how I do this question? It feels different to the other ones. I want either an audio tip or a text tip. What do I need to do to figure out what term? There's some term which is 508 at some point, and it is in this pattern. 508, that seems a bit weird, eh? Which term of the pattern will have a value of 508? Well, but what do we need to do with this 508? Maybe at some point it starts going up again. We have to use the equation, and where it's Tn, we are going to put, thank you, Edith. Thank you, Pabalelo. That is most helpful. 508 equals 3n squared minus 60n plus 301. So we need to solve this equation for n and see what we get. Now, before you start solving, can anybody give us another tip? What tools are you going to use to solve this quadratic equation? What tools can you remember from your grade 11 maths year? What did you? Oh, it's Pafunzo. Sorry, Pafunzo. What tool have you learned about in grade 11? The quadratic formula. Much so you stole the words out of my mouth. Now, I'm going to say the quadratic formula is exactly what you need to use, but there's something that you need to do before you can use the quadratic formula. Who knows what that is? Okay. You have to put it in standard form, don't you? And then you have to substitute in for n. So I want you to take my quadratic equation, put it in standard form, and then I want you to find me the answers for n. There'll probably be 2, and the question is which ones will work. Now I'm going to use my calculator. 301 minus 508. I get minus 207 equals 0, which means A is 3, B is minus 60, and C is minus 207. Can I get a thumbs up if everyone agrees with my A's, B's, and C's? Okay, next up, I want to know what are the n's going to be. maybe in case you've forgotten what the quadratic formula is, it's on your formula sheet. But here it is, just in case it's left the building for a bit. So it's b squared. So now let's put this in a bracket. Minus 4 times a. Now what was c? Oh, minus 207. Okay, I must be careful how I put this in my calculator. So this is actually going to be minus is actually plus 60. So 60 plus, and there's two roots. In fact, you know what? I'm going to do an extra step just so I don't mess this up. 60 plus minus, and I'm going to get whatever the delta value is. So 60 squared minus 4 times 3 times minus 207. My delta value is 6084 over 6. And so now I can go 6 plus the square root of 6084, close brackets, divided by 6. And the one answer I get is 23. But there's also another one, 60 minus the square root of 6084, close brackets, divided by 6. And I get minus 3. Which of the two numbers do you think is the correct choice? Okay, now lady, let us know. Which one would you choose? Can you hear me, Naledi? Or maybe that was a hand that was a mistake, but I don't know. I see in the chat, lots of students are saying, no problem, Naledi. 23 is the correct answer, which means which term in the pattern? T23 will be equal to 508. And that's it. So the 23rd term is 508. All right, everyone, you know what time it is? Who can tell me what time it is? Put it in the chat. What's coming next? It is time for a stretch. Break time. Yes, it's break time. So what I want you to do is I want you to join me in leaving your chair or your bed or wherever it is you find yourself. I want you to stand up and I want you to take 3 nice deep breaths. Breathe in. Breathe in. One more nice deep breath. Okay, and then maybe roll the shoulders a little bit to relax yourself. And then maybe like roll your arms a little bit. And just loosen things out. You do your best maths when you're relaxed. So we're getting you nice and relaxed. Okay, I feel nice and loose. I've got some oxygen. Now what I need is the blood to pump in my body. And we're going to use jumping jacks to help us get the blood pumping. And we'll start in 3, 2, 1. Let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and we are good to go. How are we all feeling? Should we do a little brain break? Good old-fashioned brain break. Let's hide this one. Who can tell me what the value of the red square is? Find the value of the red square. Ooh, my heart is pumping. Boom, 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 boom. So I think this must be 3. And if that must be 3, this must be 2. Oh, I need something thicker. And if this is 2, then what do the 2 red squares need to be? Well, in total, they need to be 8. But what does 1 red square by itself have to be equal to? So you're right. This whole thing is 8, but there are 2 of them, and so a red square has to be 4. And this is really just a sort of simultaneous equation type thing. Okay, everyone, let's rock and roll into the next part of the lesson. So let's draw one. Let's have a look at something with pictures, and then we'll go back to that other one. So it says, given the following pattern of blocks, I want you to complete this table over here. So draw pattern 5. I want you to draw pattern 5. And after you've drawn pattern 5, I want you to say done. And then we'll see if we can agree what the next pattern looks like. Time to color in a bit. How big would your square look? If I look at this, for me, I think my square looks a little bit like so draw the pattern. I think this is a 2 by 2. This is going to be a 3 by 3. So where's that going to be? 1, 2, 3. Okay, this isn't the best kind of example, but for me, what I have is I have the square inside. It doesn't look like a square, but that square, this is 1 by 1. This is 2 by 2. This square over here that I'm trying to draw should be a 3 by 3. And then the outside square should be a 5 by 5. Are we all okay with that, even though I didn't draw the prettiest drawing in the world? Fantastic. Okay, so we'll call that pattern 5. Then it says, complete the table below. 2, 3, 4, 5, 10, 250, n. What do you think is going to come next in this block over here? Let's see how alert you guys are. You're quite right. This is going to be 12. What do you think is going to come next over here? Okay, 16. Now, I've noticed something. Is this pattern that I'm currently doing with the white blocks, is this a linear or a quadratic number pattern or quadratic sequence? Is it linear or is it quadratic? This, in fact, is a linear number pattern. And so you're going to need to use that. I want you to tell me now, what is going to go in this next block over here? What's going to go in this next block over here? 12, 16, 4, 8, 12, 16. Okay, Now, I caught you guys. It's not 20. And the reason it's not 20 is it goes 2, 3, 4, 5. Now it goes to 10. So actually, it has to jump more. What I think we should do is we should build a formula to describe this number pattern. So I'm going to put here 4n. And when I look at this number pattern, what should be the number that I add on the end here? So 4 times, okay, so you're quite right here. So 1 would be 0. So this is going to be 4n minus 4. Let's see if we agree with that. So for t1, this equals 0, which is what it would be if there was something there. For t2, it's 4 times 2 minus 4, which is 4. For t3, okay, I feel like you have got a formula. Give me a thumbs up if you understand why this pattern in black describes this. Okay, fantastic. We're all happy with that. Now, can you find me what T10 is? And can you find me what T250 is? Cool. And can you find me what Tn is? First one is 36. Then the next one is equal to 1,000 minus 4, so that's 996. And this last one is just going to be 4n minus 4. Because Tn, if that's n, it's just the formula over there. If you are unsure about linear number patterns, go back to lesson 1 in this series. We did a whole bunch of content on linear number patterns. I'm going to extend this question now. I'm going to say, here is my pattern number. So we'll call it n, and we'll go 2, 3, 4, 5. And then what I want is I also want to have the number of black blocks. So B for the black blocks. How many black blocks are there for the thingy 2? There are no black blocks. How many black blocks are there for pattern 3? There is 1. How many black blocks are there for number 4? There's 4. How many black blocks are there for number 5? Or pattern number 5? So if you look at this, I'm counting. There was 0 black blocks here. There was 1 here. There was 4 here. How many black blocks would there be in pattern number 5? So because this is going to be a 3 by 3 square, how many blocks does a 3 by 3 square have in it? How many blocks are there inside there? Put your answer in the chat. I want a few more students to vote before I give away the answer here. Let the people vote. We must know what the... So this is going to be 9. Now, what if I had a 6 there? How many black blocks would there be in pattern number 6? How many black blocks would there be in pattern number 6? Can you notice anything about the numbers that are black blocks? So it's not going to be 13. If you had to imagine what the sixth one would look like, if you look at this pattern, I think this would be a 6 by 6 square, but inside this would be a 4 by 4 square. And I know I'm using green, but essentially these are the black blocks for pattern number 6. So what number is going to go over here? It's just going to be 16. Okay, now if I look at the table for the pattern with black blocks, is that a linear or a quadratic number pattern? So if I look at these numbers, is this a linear or quadratic number pattern? What do we need to check? It can't really be linear because if I look at the first differences seem to be not the same, right? So the first differences look like that, but the second differences look like this. And when the second differences are constant, we know it must be a quadratic pattern. So this is interesting. We could give you this visual, this image, and the white blocks form a linear number pattern. They go up in, what was it, 4, 8, 12. They go up in fours. Whereas the black blocks form a quadratic number pattern. And so sometimes that teachers like to throw this type of question in. Give me a thumbs up if you understand how in this particular question with the pictures, there's two number patterns that are going on. And the one is linear, the other one is quadratic. Okay, fantastic. Well, I think we can move on. Are there any questions? Does anybody want to ask a question before I move on to the next example? Now is your time to shine if you wish to ask a question. Okay, should we okay, let's try. Should we try this one? Who can tell me what the value of x is going to be? Okay, everyone, what are we going to get? I suppose we have to look at the first differences. Let's have a look. And then what's this? Oh, sorry, that's actually +3. So if you get confused, remember, you can just go -6 minus 9. So -6 minus 9, and that actually goes up by 3. And then it goes up by 7, and then up by 11. So what is it going to go up by to get to x? I think it's going to go up by 15. So what is x going to be? You see how I'm using the first differences? Like, I know it's a quadratic pattern. And so I'm looking, and it's going up by a certain amount each time. So what does the x have to be? I think I have to add 12 plus 15, which gives me 27. Sorry, not that, x should be 27. So let me write this above this so it doesn't get confusing. That should be 27. Thanks, Pabalilo. Can you find me the nth term formula for this pattern? So I've got this number pattern, -9, -6, 1, 12, 27. I want to know what is the general term formula. I guess I need to, yeah, I'll let you figure that out. What is essentially what they're saying is, what are the three values? So the first differences are 4, which means 2a is 4, 3a, now be careful, the first difference is actually 3. It's the first difference is that value there. And then a plus b plus c must be -9, which is this value here. But I still need help finding what a, b, and c are. Okay, let's have a look. So what we have is we have a is 2. If I put a is 2 here, 3 times 2 is 6, but then I bring it across, I get b is -3. And then if I get 2 minus 3 plus c is -9, this is -1, which becomes +1, so I get -8. And so what I get is 2n squared minus 3n minus 9. Can I have a thumbs up if you agree with that? Thumbs down if you disagree? All right. So we're okay with that. Okay, now something quite strange happens. It says a new pattern is formed by adding 3 to each term in a given quadratic pattern. Write down the general term for this new thing, Pn dash, or essentially Pn equals, okay, so this new one, where should we start for this one? I think we have to start by making, there could be a quicker way to do this, but I'm going to go the long way. If I add 3, this should be minus 6. This should be minus 3. This should be 4. This should be 15. And this would be 30. Everyone, thumbs up if you understand how I got a new pattern, Pn, is formed by doing that. Now, I'm still not sure exactly what's going on, but I'm going to, okay, maybe I lost you. Okay, some of you are lost. It says a new pattern is formed by adding 3 to each term in the given quadratic pattern. They're referring to the quadratic pattern above. So I go minus 9 plus 3, that gives me minus 6. Minus 6 plus 3 gives me this, and so on. Can I have a thumbs up now if you understand where I get the blue? Okay. Now, I'm just exploring this. But if I look at the first differences, okay, what do I notice? Well, the first difference is still going to be 3, and that's going to be 7, and that's going to be 11, and that's going to be 15. And so what we're going to find in this case, the second difference is going to be 4, 4, and 4. Okay, well, that's kind of good news, because this is also a quadratic pattern. So all I'm going to do is go through, I'm running out of time, but I'm going to go 2a is 4, and then a is equal to 2. So that's the same as the original equation. But now for the second step, I'm going to go 3a plus b. What's going to happen there? What's 3a plus b going to be equal to? C is minus 8. Did I make a mistake? I'll go back now, Pepperletto, just to check. So in this new pattern, the first difference is just 3. So what I have here is I have 3 times 2 plus b equals 3. B is minus 3. Can I have a thumbs up if you agree with my B? So far, even though I've added 3, the term hasn't changed at all. Okay, there must be some difference, surely. So I go a plus b plus c. What's a plus b plus c equal to? Well, the first term now is minus 6, so at least this has changed. So now what we have is we have 2 plus 3 plus c is minus 6. What is c equal to? Well, 2 plus 3 is 5. Take it to the other side, and I get, what do I get? Let's just make sure I've got this right. 2, this should be minus 3. Hold on. I was getting a bit excited there. 2 minus 3 plus c, which means that's minus 1, which means it becomes plus 1. So c is minus 5. So what is the equation of the new, or let's call it Pn, not Tn, Pn is equal to 2n squared minus 3n minus 5. And let's just check that one more time just in case. A plus b plus c is minus 6. 2 minus 3 plus c is minus 6. That's minus 1. That becomes plus 1. And we get that. Okay, now the last one, we don't have time for this, but I'll just show you how we would do it. Which term of the sequence found in question 3.3 has a value of 400? So now they're talking about Pn, and all we would do is we would say we make 400 equal to 2n squared minus 3n minus 5, and we would solve for n. Give me a thumbs up if that makes sense to you. Give me a thumbs up if that makes sense to you. Okay, fantastic. All right, everyone, it's almost time for the end of the lesson, but you know that this is a quiz day. So what I'm going to do is I'm going to put today's quiz in the chat. I think a lot of you can whack this out the park in 10 minutes if I just put it for you now, and I want to encourage you to do it now. Get that stuff stuck in your head. That is the quiz over there. And then I'm going to check my form to see if there are any. Okay, so we've got this new thing now where at the end of the hour, the lesson ends. But if students want, they can submit questions. And I was just looking at my question box, and people have requested a timelines question from finance section. So I'm going to do one question on that tonight. But before I start that, give me a wave if you're leaving class now. And then if you're staying around, in about a minute's time, I'm going to start with a harder financial timeline question. Thank you, everyone. It was great being with you today. I hope that you have a great rest of the day. And let me go and find that timeline question that was requested. It's a little bit vague. Not vague, but you can't see it so well, but I'll do my best to bring it into view. So you probably can't see it so clearly, but I will put it here. Okay, so it says 150,000 is deposited into an investment account for a period of 6 years at an interest rate of 12% per annum compounded this for the first, and then 8.5% per annum compounded yearly for the rest. It then says there's a deposit and another deposit. Calculate the value at the end of 6 years. Okay, what I'm going to do is I'm going to start with a timeline, and I'm going to start with it in years. Or should I? No, maybe I should. Let's go with years. T0 and T6. Give me a thumbs up if that makes sense to you so far. Because the whole thing is for a period of 6 years. Now, it says for the first 4 years, so I'm going to say T4, something happens, and then for the rest of the period, it changes. And the thing that it looks like to me is the interest rate for the first 4 years is 12%, but it's compounded half yearly. So I divide by 2 for when I'm talking about this bit. But when I'm talking about this bit over here, it says it's 8.5%, so it's 0.085, but it's compounded yearly, so that's actually divided by 1. So basically, half yearly for the first 4 years, and then, okay. Again, give me a thumbs up if you followed this bit. Bye, Amochnalang. Have a good one. Okay, so now we have to decide what about the things that are actually going into this pot. There's 150,000 that enters the question here. And then a deposit of 8,000 is made after the first year. Okay. Let me put a little T1 on here. And below T1, I put my 8,000 here. A deposit of 8,000 is made into the account after the first year. So it's at the end of T1. And then another deposit is made 5 years after the initial investment. So I'm going to call this one T5, and it's going to be over here. Because these amounts of money are coming into the story at different times, it's nice to have them at different places. Give me a thumbs up if you followed this bit so far. Now, these things are all about the compound growth formula. So I'm going to use the compound growth formula. But what I'm going to do is I'm going to start with just 150,000. And the 150,000 is going to go on a journey. It's going to go on a journey for the first 4 years. And the interest rate in those first 4 years is this. But the problem is I'm not going to put this in years. Up here, I'm going to put it in terms of half years. So how many half years are there in the first 4 years? If you think about 4 years, but it's divided up into half years, I think that this has to be 4 times 2, or 8. Sunday, you're with me, absolutely. But the 150,000 has only grown to here. It's got to keep on growing. And so for the next 2 years, all I'm going to do is I'm going to put this little bit here, and I'm going to treat this value as the original value. And I'm going to go 1 plus 0.085 over 1. Now the interest rate is per year. How many years do I have left for the 150,000 to grow? I think that because it's 2 more years here, this has to be 2. And the reason I'm not making it bigger is that there's a 1 there. So basically what happens is you take how many years you have to grow, and you times it by the number you're dividing the interest by. Here you had 4 years, but you times it by 2 because of the 2 here. Give me a thumbs up if you understand that. Why this is a 2, but that's an 8. Okay, now, here is the only thing that's different. I still have these other bits over here. So this bit, this 8,000, it has to grow through this time period. It's 1 plus. But now what's going to be over here this time? And it's not going to be an 8. How many years does the 8,000 have to grow for? It has to grow for from this point. And it has to grow for 3 years, but it's half years. So this is going to be 6. Then after that, it has to keep growing. It has to keep growing for 2 more years. And the interest rate is still going to be that, but it's got 2 more years to grow. And so it has to grow for those 2 years. So it started here and it grew, and then it grew for 2 more years. What have I not dealt with yet? What's the final thing I need to deal with to solve this question? What have I not dealt with yet? What have I left out? There's something I've left out. I dealt with this. I dealt with that. There's something else that's going to haunt me if I don't deal with it. what about this 2,000 over here that's just chilling? We need to take into account how much that is worth at the end. How long does the 2,000 have to grow? It's at T5, it's only got 1 year to grow. And because this is not 0.12, this is 0.085 over 1, because the interest rate is per year, I just put how many years are left. And so everyone, in the very end, if I was to get the answer, what I would do is in my calculator, I would type in this, but I would press equals every so often just so I don't have to type this whole thing all at once. So like literally I would do 150,000 times by open bracket 1 plus fraction. And then I would basically, once I got to a place where I'm running out of space, I'd press equals and then go plus again. And then I would do that from there. All right, everyone, I'm going to call it a night for tonight because you can go from there and work the rest out. But just give me a thumbs up if that helped in terms of how to lay out that question. Well, that is fantastic. And I did see some other questions from students on functions and stuff, which I will look at in future lessons. And don't be afraid to send your questions in to the question box so that we can keep adding these extra little bits at the end of the sessions.